All right, knock out some homework. So find the inverse of each function. Too easy. So step one, this gets very repetitive real quick. So step one, y equals x plus 3. Swap x and y. Solve for y. So x minus 3 is equal to y. And then last step, change the notation of y to f inverse. So the process is pretty straightforward. Like it's very mechanical. First do this, then do this, then do this, then do this. So y is equal to 7x plus 18 over 2. We're going to swap x and y. And now we're going to solve for y. Multiply both sides by 2. Cancel, cancel. Subtract 18 minus 18. So clean this up a little bit, right? Because that's going to cancel. So 2x minus 18 is equal to 7y. Isolating y cancels. So y is equal to 2x minus 18 all over 7. So f inverse is going to be 2x minus 18 all over 7. Hey, let's go. All right. Number 3. F of x is equal to 4. Therefore, y is equal to 4x, or f of x is equal to 4x. Therefore, y is equal to 4x, which means x is equal to 4y, which then means cancel, cancel. F inverse is equal to x over 4. Y is equal to negative x plus 3. Switch x and y. Solve for y. Minus 3 minus 3. X minus 3 is equal to negative y. Solve, isolate y. Divide everything by negative 1. Negatives cancel, cancel. So f inverse is equal to x minus 3 over negative 1. All right, once you isolate y, that last step is to just basically you change y back, or you just change the notation of y into f inverse. Okay, to be correct, technically this is h inverse. Whatever, it's the inverse of the thing we just solved. It's the inverse of the thing we just solved. So h inverse. Did I do that up here? F inverse. Yeah, I did. So this should be G inverse. G inverse. And the first one should be H inverse. I guess if you want to be absolutely correct. Either way, it's the inverse. It's the inverse of the function, right? All right. G of x. So this is going to be y is equal to, actually look at it like this. You always got to look for shortcuts. Why? Because otherwise you'll be here all night. So switch it to y. Change g of x to y. Then you swap x and y. And then you isolate y. Minus 1, minus 1. X minus 1 is equal to negative 4y. Isolating y by dividing by negative 4. Cancel, cancel. So y is isolated. So now we can convert to G inverse, which is x minus 1 over negative 4. You can put a box around it. Let's go. All right. F of x is equal to 1 over x minus 2. We converted it to y. Now we're swapping x and y. So x is equal to 1 over y minus 2. Isolating y. So I'm adding 2 to both sides. So x plus 2 is equal to 1 over y. All right. So here's a couple of different ways, depending on your comfort level of how to solve this, right? Like if you're nice, then you know that these two things can interchange. It's like, well, how do you know that? Because if you didn't know that, the way to isolate y, you have to multiply both sides by y. Y is going to cancel. Then you have y, or instead of rewriting it, the next step would be to still isolate y. So I would have to divide both sides by x plus 2, which on the left side cancels, which makes y is equal to 1 over x plus 2. So if you look back, if you, I guess, rewind the tape, and you see that you have something, let's just say x is equal to 1 over y, right? Yeah, something that looks like this. This is essentially what we had. Well, then you can just swap these out, right? You can interchange those two. Let's say that you don't like my example. So let's just say, let's use the exact thing we had. X plus 2 is equal to 1 over y. All right. I can interchange. I can put this in place of that and swap those two. This is a very, very legal move. So then, without even doing all the things that we did, you can say, oh, okay, well then y is equal to 1 over x plus 2. And that's exactly where we're at. That's exactly where we're at. So, final answer, f inverse is equal to 1 over x plus 2. Number 7. H of x is equal to the square root of x, all minus 3. So change it to y. Swap x and y. And then isolate y. So adding 3 to both sides, we get x plus 3 is equal to the square root of y. Now we want to isolate y to get y strictly by itself. So that means I have to square both sides. That's the only way to undo a square root. So that's going to cancel. And now y is by itself. Therefore, h inverse is equal to x plus 3 all squared. Number 8. G of x is equal to 2x squared plus 3. All right, step 1, change g of x to y. Swap x and y. Isolate y. So to get to y, we have to first subtract 3. X minus 3 is equal to 2y squared. All right, so here's where there's a bit of a fork in the road. And what operation do we do first? That's the question. Do I divide by 2 or do I take a square root? I would divide by 2. Now, does it truly matter? It's a matter of perspective. So, but I think getting rid of the coefficient first, it's a little bit cleaner than taking a square root first. So now we have cancels on the right. Now I need to undo the square. So that means I have to take a square root now. So if I take a square root now, the square root's going to cancel the square root. So I'm going to clean it up a little bit. On the right-hand side, we have y. Left-hand side, plus or minus, right? Because I introduced the square root. The square root wasn't there. I brought it to the table. Therefore, I have to bring a plus or minus. X minus 3 all over 2 inside the square root. And then you change y back to G inverse. All right. I'm wondering if I should show what happens if you square it first. It comes out to the same answer. Like, it just might look a little funny, but it comes out the same way. So we have x minus 3 is equal to 2y squared. All right, so let's just say you square root first. Square root both sides first. So then this is going to be plus or minus square root of x minus 3 equals square root of 2y. Technically, that's not correct, because when we square rooted the 2y squared, the 2 got square rooted for sure. The y got square rooted, but then the square root and the square canceled each other out. So the y is technically outside the square root now. So then to isolate y, divide both sides by root 2, cancels on the right. And on the left-hand side, we have basically the same answer, right? Because I have a square root on top and the square root on bottom, you could actually rewrite that as one big square root. And that's exactly what we had for G inverse of X. So it really doesn't matter which one you do first. It just depends on your comfort level, right? Like if you're nice, can you remember? Because I almost forgot. Can you remember that the Y comes out? So it's a matter of opinion, I think. All right, let's keep it moving. Find the inverse of each function, then graph the function and its inverse. All right, so G of X is going to be 3x plus 2. So I'm going to graph the function just because it's already here. So y-intercept is at positive 2. I'm going to do it in black. Positive 2. And then the slope is 3. So up 3 over 1. 1, 2, 3 over 1. Over 1. Over 1. Over 1. All right, so here's G of X. 3x plus 2. Now I'm going to find the inverse. So doing what we just did, I'm going to change it to y and then swap for x just to save some room. So steps 1 and 2 I did instantly. Minus 2 minus 2. X minus 2 is equal to 3y. Divide both sides by 3. So G inverse is equal to x minus 2 over 3. Now you might be asking, how do you graph this? So remember, y equals mx plus b. That's the graph of a line. So what this is saying, one way you could do this, if I have 2 terms on top, 1 term on bottom, you can definitely split the denominator up. So now we'll do this in red, right? Because my G of X is going to be negative 2/3. That's the y, or G inverse of X is going to cross the y-axis, the y-intercept at negative 2/3. So negative 2/3. And then the slope, right, 1 over 3. So I'm going to go up 1 over 3. up 1 over 3. 3. Okay, so then connect the dots. And there's the inverse in red. The inverse is in red. The original function is in black. So a nice characteristic is that there's a very particular line, y equals x. I'll dash it out. Which you'll come to find that when you have a function, its graph, and its inverse, that it reflects the graph. The inverse is reflected across y equals x, the blue dashed line. So that's a nice little feature. You might have to stare at this for a little bit to understand what I'm saying, but yeah. Do I want to go more in depth on that? So I will note this, or one thing to note, right? If you have g of x and x, right? I don't want to write this in blue. Let's do it in black. So if you have an x and a g of x table, whatever your x's are and your y's essentially, when you reverse them, right? When you swap the columns, to make this g of x and this x, well, then this is really the inverse. So it just swaps the x and the y's, and then that's what reflects it across y equals x. So it's pretty interesting when you like actually study it. All right, let's look at f of x, or number 10. F of x is equal to 2x minus 1, all divided by 3. So again, rewriting this in a fashion that we're used to looking at, you can split this up. When there's 2 terms on top and 1 term on bottom, you can definitely split that denominator up, and this will be 2/3 x minus 1/3. So the y-intercept is negative 1/3, and the slope is going to be 2/3. So up 2 over 3. Up 2 over 3. 2, 3, down 2 over 3. All right. Okay, so here's f of x in black. All right, I'm going to find the inverse. So let's do. So I can either use the original one or I can use the second one. It truly doesn't matter. So let's just stick with the original. The second one looks kind of fun though, don't it? All right, either way. If I swapped x and y, so I haven't done that yet. So x is equal to 2y minus 1 all over 3. Multiply both sides by 3. Cancel, cancel. I'm going to add 1. So 3x plus 1 equals 2y. Divide everything by 2. Cancels on the right. So f of x, inverse, is equal to 3x plus 1 all over 2. So remember, you can you can separate the denominator So 3/2 x plus 1/2. So now, graphing this, the x-intercept, or correction, the y-intercept, is positive 1/2 up 3 over 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And then just, training your eye. It's like, okay, are they really inverses? Well, if you remember the dashed line that goes through y equals x, you can see, like, ask yourself, like, is it reflected? Like, yeah, it's turned around. It's reflected over this line. The more graphs you look at, the more you'll see it. But yes, that is the function and its inverse. All right, number 11. So actually 11 through 16. So we need to state if the given functions are inverses or not. So let's keep in mind what it means for a function to be for functions, right? Two functions to be an inverse. So we're going to compose each function with the other and hope for x. Then we're going to switch and compose the functions the other direction and again hope for x. If and only if they both equal x, right? Both compositions, then they are inverses. If for whatever reason they don't yield x, right? They don't output x, then they're not inverses. Specifically, they have to output x, both of them simultaneously. So let's look at number 11. Doesn't matter which one we start with. I'll leave that up as a guide. So if we go f of g of x, so I'm taking g and I'm inputting it into x. So 1/2 x is going to be in red, the input, plus 3/2. Okay. We have to simplify. We have to distribute. So we're going to get, so 4 times 1/2 is 2. Minus, so 1/2 times 3/2. 1 times 3 is 3. 2 times 2 is 4. X plus 3/2. All right, I can already tell you that looking at this is not going to equal x, right? Because we want to see that it equals x. So right away, I mean, I can combine like terms, but this will not be x. So right away, this is not inverses. But there's no way. There's no way. Okay, let's do, which one do we want to do? It really doesn't matter which direction. So f of g of n. F of g of n. So again, g is the input, and it's going into this n. So -5 plus 6 n, -12 minus 2n over 3, all over 5. Okay. All right, couple things I'm thinking. Like, there's multiple ways of doing this, right? It's your level of comfort in algebra. Like, what do you see first? Me personally, I see a big fraction. I have two terms on top, right? I have -5 is one term, plus the other term, 6 times something. So I can actually break up the denominator. So negative 5 over 5 plus 6 over 5. And then this is going to be negative 12 minus 2n over 3. Okay. This can be rewritten even further. So simplified, negative 5 over 5 is negative 1, so cancels. Plus, all right, this is going to be, so a couple things can happen here. The 3 and the 6 can cancel, making that 2. And then the 5 will be in the denominator. So, in this 2. So 2 minus 12 minus 2n all over 5. If I distribute, I'm going to get negative 1 plus negative 24 minus 4n, again over 5. This isn't going to equal x, or in this case, n. There's no way, right? There's no way that this is just going to equal n. So I could put the negative 1 back into the fraction, but that wouldn't do anything. Watch. If we didn't cancel the 5s, and put it back together, we would get negative 29 minus 4n over 5. And again, that's not right. Oh, it's my bad. So at the end of the day, it's not just the single variable, right? It's something other than that. So I feel this is not inverses. Just double checking that one more time. It's not. There's no way. 3 cancels. Yeah, not at all. All right. 13. Same thing, right? We're going to f of g of n. You know what? Let's switch it up. Let's do, first, let's do g of f of n. So this time, that f is going into g. F is the input now. I'm putting it into g. So here we have 4 negative 16 plus n over 4 plus 16. All right, simplifying. The 4s are going to cancel. Negative 16 plus n plus 16. Oh, look, 16s are going to cancel, leaving behind n. All right, so right now this looks promising. But we can't assume that the other way is going to work out. We have to show it. So f of g of n, I guess we could have started there. This is going to be g inputted or composed into f. So we have negative 16 plus n, but in that case, or our case, is 4n plus 16. All over 4. Okay, before we start canceling things out, Let's understand what's happening. Up top, things are being added, so I can actually drop the parentheses up top. In doing so, I'm going to get negative 16 plus 4n plus 16 over 4. So in the numerator, I have negative 16 plus 16. Cancels, cancels. So 4n over 4 cancels. So we get just n. And here we see that they both equal n. So they are, in fact, inverses. Inverses. Because we compose both functions into each other, and we got just a single variable to come out, they are inverses of one another. That's nice. All right, 14. Let's go with f of g of x. So g is the input. So this is going to be negative 4 over 7, parentheses, 3 halves x minus 3 halves minus 16 over 7. All right. Distributing the 4/7, the negative 4/7, we're going to get negative 12 over 14. That reduces. So distribute. So negative is a positive. 4 times 3 is 12. 7 times 2 is 14. Minus 16 over 7. All right, so combining some like terms here, or actually we can reduce this. If this reduces to 6 over 7, then we're going to get negative, look, this reduces also 6 over 7. So negative 6 over 7x minus 10 over 7. At the end of the day, it's not just x, right? It's not just x. There's no reason to even work out the other composition because it's not inverses, right? It has to be x. Had it been x, we'd work out the other way and then see what would happen. But this is not inverses. Okay, 15. This looks interesting. So let's see. F of n, f of g of n, rather. So g is my input going into n. So negative, parentheses, three plus n cubed plus 1 cubed. Okay. So this is going to be negative 4, right? Because 3 plus 1 is 4, n cubed. Okay, that's it. There's nothing. Well, it's cubed, right? But there's really nothing we can do. We can't simplify it anymore. I can expand it out, but if you expand it out, you're gonna find out that it is not gonna be just n, right? It's gonna be a whole lot more. So we can say not inverses. Okay, 16. Is this the last one? It is. Let's go. All right, 16. First off, this needs to be x. I don't know why that's an n. All right, that needs to be x. All right, if I do f of g of x, that means g is my input into x. All right, so that means 2 times 4 plus the cubed root of 4x over 2 minus 2. Okay, this is going to be cubed, actually. Cubed. All right. What am I thinking? I'm thinking that I can lose these parentheses here. Right, because I can't do anything outside the parentheses. All the magic has to happen inside the parentheses. So first thing I'm noticing is that I have a fraction and a non-fraction. So I'm going to combine these two together. So I need a common denominator. Common denominator is going to be 2. So 2 is really, this is really 4 over 2. Right, that's the same as 2. So now that I have a common denominator, we can say 2, 4 plus cubed root 4x minus 4 over 2. Right? I had a common denominator 2. So they combine into one denominator, and then the numerators combine. And that's nice because what's happening here is that I have a 4 and a minus 4. So cancels. All right, with that being said, 2 cubed root 4x over 2 cubed. All right, with the cube, I'm going to cube the top and then cube the bottom. Cube the top, cube the bottom. So when I cube the top, I'm going to get, so this cube and the cubed root will cancel. So I'm going to get just 4x over 2 cubed, right? Because I have to cube the top and cube the bottom. So 2 times 2 is 4 times 2 is 8. Okay, a couple things cancel here. Well, 2 times 4 would be 8. So 8x over 8. And then the 8's cancel, leaving behind just x. Okay, so that's nice. That's nice. Now let's try it the other way. I'm going to do g of f of x. G of f of x. So f of x is the input, and all of that is going into g. So 4 plus cubed root of 4 times n. Okay, well, n in this case is going to be 2 x minus 2 cubed all over 2. Here, so you can see it. So the 2, x minus 2, that's the input. That's f of x. That's f of x. All right. Simplifying this a little bit, we're going to get 4 plus the cubed root of 8, because 4 times 2 is 8, x minus 2 cubed. All right, over 2. So here what's happening is that because I have, right, the argument, that's what we call the part inside of the square root. There's 8 times something, right? The something is x minus 2 cubed. The cubed root can apply to both of these terms individually. So the cubed root of 8 is really 2. And then the cubed root of something cubed, basically it's going to cancel, leaving behind x minus 2 all over 2. All right, when I distribute, I'm going to get 4, right? Because this is a completely different thought, so let's not get confused here. 4 plus 2x minus 4 over 2. Well, 4 minus 4, that's cancels. And then when those go away, the 2's will cancel, leaving behind just x. So we've showed that when we do both compositions, that they equal x, and they are in fact inverses. All right, hopefully this helped. Catch you on the next video.